Yo, what's up? We're going to continue with the mesh parser today. I'm just going to jump straight into it. So yesterday, I was stuck at a problem that we had various triangles did not get included in their polygon. But some change yesterday fixed it. Not a code change, but probably a import change. I've tried to pinpoint it by looking at the VOD real quick just before the stream, and while we were recompiling the scene, that's when something happened. So I still don't know exactly what setting changed it. We're gonna look into it. We're gonna give it a couple more minutes, maybe even a half an hour, and then we're going to continue, because now we have this one split up in a very nice polygons. There's still some question marks though. For instance, the angle threshold here. What am I like? We don't use it currently. We just we do it like this right now. So for every neighbor, we add it to the polygon. I'm a little bit worried. Like this still means that whatever triangle has this edge on this side and the triangle on this side, they don't share an edge, even though they technically are. And I think that has to do with how the meshes are processed when you import them into Unity. Initially I thought it was this smoothing angle had something to do with it, but we don't get a change here either way, right? So honestly, I don't know. Yeah, there we go. When we recompile it now, we get it like this. Okay, beautiful. A extremely weird polygon. We get one here. Hey, what's up, Jax? It's just when we import, I'm just playing around when we import a mesh, or when you import a mesh in Unity, you can choose to either import it with the normals or calculate them. What we're building, on the other hand, is like a mesh parser. I want to be able to parse a mesh and gather information about it. So I'm just trying how our parser works with various settings here. But it's good to know. So oh fuck, I'm beating myself up right now for not remembering the name, but I know that someone mentioned this in YouTube chat yesterday. That we might need to reload domain reload scene when we do changes like this, because we can see here now that we use the old data to calculate this, and if we force a recompile, we can do it by this, we're going to get the correct result again. Okay, that's pretty cool. I'm wondering, okay, we're going to continue with this. and see if we can. So the next step, now that we have our polygons, I also want to I want to be able to create a circular polygon. I want to be able to walk from one vertex clockwise around the polygon and get back to the initial point. So we're going to try and do that. Because the main reason we want to do this is because then we want to take the polygon and we want to scale it. So we scale it inwards here, and then we can start getting random points. Okay. We will probably work with this one quite a bit, but let's add back this, or for a long time, I mean. Let's add this one back, and okay, so if we add that one back, yeah, we're doing minus. It's a little bit weird that only this one gets split up, actually. I would have thought... Okay, beautiful. So what I want to add back now is this. So the idea here is that we calculate the polygon loops, basically, or the boundary with a proper direction. And let's see here, we do it like this. So first of all, we get the boundary edges. This one is, we know that this one is correct because we have printed it. And so now this is basically a list with edges, and every edge here is a boundary edge. Now we just want to figure out the direction we should walk here. And I'm just not entirely sure if it's possible to do it like this. It doesn't make much sense to me. Let's see here. Like, I'm a little bit worried over the fact that we do this here. So we order the vertices based on index in edge. Yo, what's up, Star Platinum? Yeah, we're going to continue onwards now because now we have proper polygon calculations. It was probably something related to when importing the mesh in Unity. So now we're going to try and figure out the correct way to walk through this polygon. So what we do here is that we create a dictionary where we have a vertex key and vertex value. And for each edge, we set v1 as the key and v2 as the value. And then we want to walk it through like that. But I'm a little bit worried that, yeah, we probably can't do it like this since we alter these two. Or the direction of them, that is. So... Yo, what's up, Apukas? I see this feature is quite complex. Yes, indeed. And what worries me is that this is only the beginning. Yeah, I don't know if we can do this. We need to figure this out in some other way. Jax, did you major in computer graphic at university or just personal hobby? I did major in computer science, but it was more towards computer vision and image analysis. Yeah, we're gonna have to do this in some other way. I wonder what we can use to calculate this. Okay, so let me draw some stuff. And maybe it will become clear. Apukas, I feel you, man. Yesterday I dived deeper into character customization, data loading, syncing, saving, and making it work with the UI dynamically. Having a hard time to make it work without bugs. Yeah, so when it comes to character customizations for your game, how deep are you diving into it? Like how much will the player be able to customize the character? Is it some modular system, or are you going like Bethesda bone scaling approach, or what are we talking here? Star Platinum, I still don't know how your polygon quote-unquote boundary. Why quote-unquote, man? I'm just kidding. It works though. But on the rock, there's a small triangle and maybe a small polygon comparing towards the eyeballs. Def checking that out too. I mean, it's not too complex. Let's say that this is our polygon. So this is a polygon that consists of 3 triangles. These 3 triangles, let's do T1, T1, T2, T3. let's say that all of these triangles share normals, then they should be considered the same, or we want to merge them into the same polygon. And by removing these inner edges, we create the boundary polygon. It's just a polygon that includes all of these three triangles. Okay, but anyway, let's see. So here's what I would like to do here is we take edge 1 and then we go, we add this as the key, this as the value, and then we just loop like that. Or that's what we are trying to do. So that would be, we have 0 and then we take the value of that one, which is v1, and then we check for something that has v1 as a key, and then we take value of that. And that way, if we do it like that, we are going to walk like this. But the problem appears here, because edge 5 has this one is v1 for edge 5 and this is v2, which means that if we add this one as a key and this one as a value, so this is the value, this is the key. So if we take this one and use it as a key, we don't get any result. But maybe that's okay. Maybe we can just, maybe that's the end. I don't know. I don't think we can make that assumption. If we had a way more complex, yeah, I don't think we can make that assumption at all. So what bothers me, or I think we need to figure out... Yo, what's up, Prosto? Lurking from the bushes, I take it. Bushes. We need to save the direction of our edges. Star Platinum, why do you go through vertices? How would we do it otherwise? The thing is, like, if we have this polygon like this, I want to gather information of this one because I want to, based on vertices, because we want to scale it. Eventually, I want to scale this one down to here, and to be able to scale it like this properly, like adding a margin, we're gonna need to know normals and bitangents and a whole lot of stuff. Prosto, what is that? This is our polygon, or it's a sketch of our polygons. So we have our polygons. Now we just want to, so here we have all our polygons. We have the blue one here, pink one here. We get some overlap here, but you can take my word for that this edge is actually pink and green. It's just that we just draw the latest one, unfortunately. And now I want to calculate, or I want to get the, I want to be able to walk around this polygon, because if we can, then we know the, then we have the normal, tangent, and binormal, and we can do some cool scaling with it, I think. I think we're gonna do it like this. When we do our edges, we're gonna do some more based on this one. We are gonna do some normal. Yeah, I don't know. Yeah, we're gonna do it like this. And then I wanna do... I think we're gonna do this. Vector 3 normal. Fuck. Normal. Do I have... One sec. Okay. My keyboard was fucked up. Let's do get private set. Yeah, I mean, it's a struct. I don't think we need to do it like that. Let's just make it public. And then we have public vector 3. We were gonna go tangent and public vector 3 by normal. And then we do... The first thing we do here is star platinum weight. Why do you need a margin? I think I went through it pretty clear yesterday, but just to go through it once again. If we want to spawn an object that looks like this within this polygon, we don't want to spawn it so it hangs out from the outside, which means that we take the radius of whatever we're trying to spawn, and then we move it in like this, and then we know that it's safe to spawn this object anywhere within this without it hanging out from the polygon. So even if we get worst case point after the margin, like here, and we spawn it, it's going to be touching the edge, but not going over it. Hope that makes sense. I think that's as clear as I can explain it. Maybe we'll see. The first thing I want to do here is calculate normal, tangent, and binormal. And it's a little bit weird, but if we have a line or an edge from V1 to V2, like this, I'm gonna assume we're gonna do it like this. Our normal is going to be, we take the normal of V1 and the normal of V2, and we take a, like, the in-between of them, basically. That's going to be our normal for the edge. The binormal is just going to be the direction of it, and then we can calculate the tangent by doing cross product between these two. But the most important part is going to be this one, the direction. Because if we know the direction, we know the winding direction, and then we can walk through the polygon, I think. We could make it even easier for us. Oh, what is it? V2. What is it? What is it? It's V2 minus V1. But dot position and normalized. And then we do tangent is equal to and then we do this. And the reason we do this is because I wonder if I even want to do this, honestly. But we want to be able to compare them like this. We're gonna see here, one sec. Let's do get random point on polygon defined by number of defined by vertices. Fuck, I hate rejection sampling. But if we're gonna do uniform sampling via triangulation, that means that we're gonna go to polygon and then we're gonna scale it, and then we want to calculate the triangles again, which is weird. Works well for complex or concave polygons. That's beautiful. But oh hell yeah, we're gonna use that. Yes. So we keep the triangles. It's just that we. Like I'm thinking about changing these to class instead. So if we change one of them, we change them all. And then we don't need to do this shit. Maybe that's preferable. A little bit slower, I guess, but because we want to scale it based on polygon. I'm pretty sure. I can't imagine how one would scale it. We want to figure out the Am I calculating the binormal and tangent in the correct way? Oh, yes. Maybe. Let's show. I want to show not polygon boundary, show polygon triangles. Here we go. So the idea then is that we take this point, and this point, and we move them all in according to some rule. We want to move them. We want to move them in on the plane or the triangle. Is that possible? Okay, I think we get the correct tangent. So we want to move them in by the tangent. Is that enough, actually? If we just have the tangent, we move them in by some distance according to tangent. And then we repaint our triangles. We can try it. Yeah, but I think one thing we're gonna do is we're gonna change this one to class. And then we can make it a little bit more. The idea is that we don't want to. Yeah, we're gonna leave this. But if we have it like this, we also need to check if it's null. Because if we do this, it's not value by, or it's not referenced by value, it's. What the fuck is the term? Anyway, now we, like, previously, if this was a struct, when we create a triangle and we get vertices like these, we were actually like referencing values, so duplicating each time. If we have it as a class, we're going to reference the same vertex. So every triangle that consists of meshed triangles I is going to reference the same vertex, which means that if we move one of them, it's going to move it for all of these triangles, and that's good. Wondering how would that work if we move. Hmm. That's not good. What? Why would it? 25, 29. V1, V2, we check if V1 is not equal to null. If it is null, we return false. Otherwise, we do this one. I care about this anymore. Oh yes, of course. What the fuck? Yes. Let's see. Let's see here. Do we care about these? No. Or I wonder, do we want to do it by this? No, I don't think so. Hash code, however. So when we do this, we actually call this one. And when we do this, we call this one. Yeah, of course. Um, I don't think we need any of these anymore if we're gonna go with class, and I think I want to go with class. It depends on this one, actually. Gonna create a lot of different edges. Yuyi, what's up? No, this is Unity. Yeah, when we create these these triangles, we're gonna create new edges. So the edges we might want to keep as a struct, but it feels weird. So triangle is going to be struct, edges struct, vertices class. You can show me how your game looks. You have some videos on my YouTube. I'm thinking here, like, do I want to keep this one as a struct? We're gonna have to do a lot of more changes then, and I'm afraid that we change. I'm afraid that we change. I think we're gonna go with struct here, actually. And what I think that we need to do is mesh parser. I think we need to create triangles per edge. And would it be weird to have this relationship as well? Yuyi, how long have you been doing game dev? Since 2016, I think. Apuka's modular character customization with mesh swapping and blend shape scaling is my focus. Yeah, okay, yeah. Blend shape scaling is pretty nice. The system supports 3 save slots, each storing separate progressions, unlocks, and currency. My approach uses 2 base prefabs, one for male and one for female, each containing all wearable parts like shoes, pants, shorts, hair, face. I create scriptable objects that hold data for each mesh item, including name, icon, price, and unlock status. After the play finishes customization, the system removes all unused meshes and saves only the chosen ones. Since there are 3 slots, I need to save and load data separately for each slot accordingly. I get it. Yeah, I think that's very similar to the approach I'm gonna take for my customization. But I'm thinking about going the easy, like just doing one unisex. Fuck, I don't know. Yeah, it's a hard problem, but it sounds like you've got it figured out for your use case. Keep me updated. Appreciate it. Edges per vertex. If we do edges per vertex, then we get I want to see how that looks. So if we were doing edges per vertex in this drawn example here, we would have this is a key, and this are the edges. Because what I'm thinking of doing is, so when we want to scale these vertices, we just take, so we want to scale this vertex, so then we take this edge and this edge. We don't want to take these, that's true. So we want to remove. So yeah, maybe we want to store edges per vertex here, but we probably also want to do it in here actually. Polygon, triangles, boundary edges. And maybe, yeah, let's try this. So mesh parser, we're gonna wait with this one. I don't think we need it right now. Because yeah, there is multiple ways to do it. I guess I've chosen to do a difficult system. Yeah. But I mean, what's the fun in doing the easy way, right? So in a polygon, I wonder if we want to have public dictionary vertex list edge. Edges per vertex. We calculate boundary edges like this. Boundary vertices. Do we even need boundary vertices? Oh yeah, we do. Boundary edges. So I wonder if we can do boundary vertices is equal to boundary edges dot map. What is it? Zip, 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 zip. How to, or function for flat map or something like that. Let's see here. Function for creating one list of items from a list of lists of items in C# link. Apoca's the finalizing where you think it would be on paper manageable, but turns out it was just an iceberg tip after all. Yeah. Join select many, select many, select many. But I wonder if we can use select many. Or actually, maybe we can. Select many. And what do we have here? We have edge. And I want to do it like edge.v1, edge.v2. Maybe we need to do it like this. Dot where edge new list vertex e.v1 e.v2 dot. Can't we do it like this? Not where, but select. There we go. And then select many. Is it just like this? I think it is. And then unique. What the fuck is unique in link? Distinct. Okay, maybe a little bit of a complex way to do this, but I think we end up with what we want at least. Yo, what's up, Antonino? So we have a list of edges. For each edge, we take the vertices and then we make them into, so it's a list of lists of vertices, and then we flatten it, and then we just take the distinct vertices, and then we take two lists. So now we have boundary vertices, boundary edges. I want to print the boundary vertices before we continue, just to see that it looks good. Oh yeah. For each primitives dot vertex in something like that. Yo, what's up, Kevin? I did get it right today, right? Sure as hell hope so. If we draw the vertices, we get nothing currently. Okay. Did I screw it up that bad? Boundary vertices. Probably here. Hmm. We really get a 0. Or yeah, I think I fucked up. We need to do transform point. This is one thing I did wrong at least. We'll see if it works. Yes, it does. But holy shit, did I go... Did I pick a big radius? 10 centimeters. Is this really 10 centimeters? Radius 20, maybe. It's too big at least. There we go. And we do get... in this example, we don't have... Like, all vertices are boundary vertices, aren't they? I think they are. Can we take... Do I have any other mesh I can test this on? Oh, we can take... Hey, we can try it on a plane. That's true. A plane. Because a plane has this, right? So let's see. Let's scale it as well. And then we show... There we go. Beautiful. We only get this. Oh, beautiful. Okay, this works. Nice. So, okay, this is going to be interesting, I think. Okay, so what I want to do now is I think we want to split this up by mesh parser, polygon, and relationship. I don't think we want this. Oh, maybe boundary vertices, boundary edges. I think I want to rename this one boundary edges per boundary vertex. I think the name implies exactly what it is. So per boundary vertex, we pair it. This is a relationship for each boundary vertex we have stored which boundary edge they are part of. New, and then we do for each edge in boundary edges. But maybe we can skip this one. Let's see. If edge, or let's see here, boundary edge per contains key edge.v1. If it doesn't, like this. But actually, I wonder if we want to do, maybe we want to have this as edge per vertex and we just go through all the edges. We can do it like this. And then when we have this, what we can do now is that we can go through each boundary edge and we scale them based on edge tangents. Because then again, the idea is that in this polygon, for instance, all the tangents would be like this. So if we take this vertex, we calculate a direction by taking like halfway between this one and this one. So roughly like that. And then we move this vertex in this amount. So the idea is that eventually we'll get something that looks like this. And then we get a random point within here and we are fine. And we will keep the triangle. But that is what sucks by having these as structs. If we have them as structs, like if we change, when we scale these vertices here, that's not gonna scale the vertices here. And that is, if these were classes though, it would be a-okay. But maybe that's okay actually. Because maybe if we scale it, we don't want to fuck up this one. Yeah, it's weird. So currently vertices are defined here within edges and within triangles. The fewer places we define them, the better, I would say, but fucking hell, I wonder if we want to do like this. Maybe we do triangles. Also a little bit scared if we have, yeah, if we have something that looks like, let's see here. If we have something that looks like this and we add a margin that is greater than this, and then we want to get the random point by triangle. Yeah, that's just wrong. Yeah, this system depends on the fact that we don't keep track of the triangles. Or that we recreate them. Yes. So, random point in polygon. Yeah, triangulating the polygon might be a better option. Yo, what's up, Rosie? Nice. Triangulate the polygon. Yeah, I think unfortunately we can't rely on the old triangles because now we don't want to rely on the original triangles. But fuck. I'm also thinking about the fact if we have something like this and we want to get a random point on a, what if we define the upper part of this one, so this one as a polygon, all of these, we want to keep if we generate a random point on this one, we want to keep the original triangles. Yes. Huh. Or I guess, fucking hell. Let's see here. Yo, what's up, Love? Hope today's going good. Yeah, decent at least. Hope you're having a good day as well, man. Yeah, it's just a matter of fact, or it's a matter of how we want to. The problem we're trying to solve currently is just to get objects or like get random points on a mesh in such a way that they don't overlap the outer edges. And we have the polygon boundary and we just want to scale it down. If we scale it down, yeah, it's just not enough just having the boundary, especially not in a case like this. But could we could probably sheet it, honestly. Oh, yes, I think we could. It depends on how complicated the polygon or the meshes are. Hennesil, what's up, what's up? I love it when you spend so much time in game dev, you start seeing the triangles in real life. Yes, been there. Like now I'm thinking like, should we like express this as Bezier surfaces and stuff like that? Normalized coordinates for everything? Hell no. Because what I'm like, if we take a look at this one again, let me do. Let's say that we split it like a polygon on these edges. And this is like, let's say that we want to spawn horn on somewhere random on this surface, right? We don't want to make a horn spawn here because that means that it's outside of the area in question. So what we want to take is we want to minimize this area by the radius of the base of the horn. So maybe we get something like this. And that's okay, because our boundary here, it never moves over the inner vertices, right? So that's okay. But if the horn were this big, then we would probably end up with something like, yeah, here, probably. And this is where the algorithm starts to break, because now we have a couple of vertices here. So we take these and we move them into here, but we still have vertices on the outside here. And we're fucked. It's like we want to take all vertices and move them towards a point following the edges. And this, yeah, it's just too big of a problem. Now I'm starting to lean towards more doing the repeated and try again spawn tactic. So spawn something, check if it works. If it doesn't, respawn. Kevin, yes, I said it is a hard NP. Are you sure it's an NP problem? And yeah, I'd never doubted you, like generally speaking, but for what we were specifically doing, I don't know. What did you refer to it as, by the way? Yep, I'm sure it's an NP, and I feel almost certain it is a hard NP. In the case of our simple stone mesh and the ice, in this case, it's definitely solvable. And quite straightforward. P problem, which is method. No, I mean, like yesterday you used a term for specifically what we're doing here, like generating geometry on the surface of other geometries. I don't remember what it was, but yeah. Yeah, it has a lot of edge cases, but I like... So it's the... So this is the problem we're getting right. This, extremely easy. Whoa, maybe we can... Me neither, Kevin. Okay, it's no problem at all. But I'm starting to I'm starting to lean towards, yeah, like depending on how I mean, we can decide how big we want this problem to be or how customizable. Like, where do we want to stop? One sec. Like, I'm wondering if you could do. Couldn't you just do. If you create a boundary. This is weird. But if you create a boundary. If we create a boundary like this. Okay, we can move it like that. Can we do separate selection? So we create a boundary like this. There we go. So this is our original boundary. And then we scale it. But we scale it like this. Okay, not like this. We're scaling it by medium point. Yeah, maybe like this. I don't want to go through all of this, but I'm just showing that in this case we could probably do, and then we just cut pretty much. Fuck, I don't know. Do a boolean between these, so what we're left with is here we get the opposite. Kevin, multiple booleans in runtime is costly. A booleans, generally speaking, is extremely costly, but I'm thinking like, yes, we do want to avoid it, but I mean, it's solvable. Fuck it. So if we could do this, and instead of what we remove here, we keep, and that's the mesh that's the polygon or the mesh we want to generate a random point on, and that's what we can do. I mean, yeah, then probably you can have some extremely weird meshes that fucks it up. But like something like this would be enough, but I don't want to go this far either. think it is over 0 and 2. Yeah, the good thing is that we can pretty much make this how costly we want. That's an exaggeration, but like we're probably gonna offload this work. We're only gonna do it when we spawn new creatures, and we can probably offload the initial generation to a secondary thread that just parses and analyzes the mesh and calculates spawn points. So like it's not something that will happen every frame on the main thread. So our budget is extremely big. It doesn't have to be real time. But then of course, the quicker the better. Could we do... Kevin, so you're planning to do loops divided into multiple frames. Not entirely sure what you mean by that question. I mean, the only problem, it's not so only, but the only problem we have with the current solution is if the margin becomes bigger than the outermost triangles, pretty much. So we're planning to do loops divided into multiple frames. Yeah, so right, we're gonna have a secondary thread for this, so we're just gonna offload the work. We're gonna send some parameters, and then we're gonna let it work for as long as it wants, basically. And then when it has a result, we just fetch it. We're gonna offload it to a thread that doesn't even know what frames are, basically. But that depends on, like, as I've said, worst case scenario, we just do what is the term for it? Let's see. Worst case scenario, we just do a rejection based procedural generation system. But if we can avoid it, that would be the best. You know what? Fucking hell, wouldn't... Okay, this would not be... This would be mathematically incorrect to do it like that. It wouldn't be uniformly distributed on our surface. But honestly, I don't know if I care. But you could do it like this, which I think, honestly, is not that bad. So we do this one again. So we spawn a boundary polygon, basically. And then we generate... Then we just get a random point within this polygon. And then we take that point and we check where it intersects the original mesh, and that's like we convert that point into a line and we check where it intersects the original mesh, and that's what where we spawn it. That's probably what we could do, because that means that we can take this one, we scale it, then we get a random point within here, and we check where it intersects this surface. So maybe it intersects here, and that's where we spawn the eye. What I mean is that it's not uniformly correct or uniformly distributed would be if we had a mesh, I don't know, that looks like this in here. The odds, like these faces, they cover a pretty big part of the surface, but with this system it would be a pretty low chance of the visual property spawning on them, right? But like that would work in this case. So in this case we would just take all of this one, if we have a concave or convex mesh, we're fucked, but I wouldn't worry about that one. It would be split either way, I think. It would be split before that based on polygon. Because the thing is, when we split it up into polygons like this based on angle threshold, what we do then is that we make it easy to work with. If we split it up by polygons like this, we make it easy to work with. So if this mesh looked something like, if we have a mesh that looks like if we have a mesh that looks like, I don't know, this, we would probably split it up in, so this would be a separate polygon, this would be a separate polygon, this would be a separate polygon, this as well, this, and then we would have this. So in this case, we would probably do something like, and maybe we'll do it like this. Then we do this. Do we get this problem actually? Yeah, we might get that problem as well. That's true. So when this one moves in like this and this one moves in like this, They are gonna intersect. That is true. Okay, I thought I could make it nicely, but maybe we can't. Can we scale? Can we do something in between? Can we scale this polygon and use it as our boundary for rejection? That would probably be possible. But we can do it by rejection and moving it. But would that be weird? So I guess that would be if we just do distance of, or calculate distance to polygon between polygon and point. Oh yeah, we just check for each polygon if we're inside. No. That's a very specific case, isn't it? Because if we do something like this, like we generate a random point based on... One sec. If we do a rejection-based approach, but we reject it based on the polygon we have calculated, I think it's fine-ish. That should be a-okay. So that's true. No, that... No. Hmm. Yeah, okay. True. Yeah, it's probably something like this we're gonna have to do. That's weird. So what would be the easiest way to reject it then, based on... We have quite a lot of information. Hmm. You know what? That also depends. What we could do is, or what I thought we could do, but probably not, is... like, we generate random points based on triangles. So when we generate on one triangle, we check, does this triangle have is any of this triangle's edges a boundary edge? Yes. If so, is the point... What's the distance between the point and that edge? If it's less than the radius, then it's an okay point. But once again, if like the radius is extremely big, this might fail. because then, like, we might get a triangle within. So if these edges were making the boundary, and we get this triangle, and we get this point right here, and the radius goes outside of here, we have no way to check it, because we're going to compare to this edge. Or actually, we're going to check, do we have any boundary edges? No, we don't. Okay, spawn it, basically. That sucks. I'm pretty fucking sure we could solve this if we were to express our surfaces in a bit more, in a way more complex way. Or a ray casting approach as well. Is that a is that the best way to do it? Calculate the boundary, get a normal, get a center position. So we have a center position and a normal. So from that center position, Yeah, I'm still, if we have the polygon defined by the outer boundary here, non-planar, if we scale it inwards, or we just make it smaller, actually. And we scale it inwards, and then we get a random point within it. And then we do a ray cast to that random point where to check exactly where it intersects the mesh, and that's where we spawn the object. Would probably work in most cases. I can't really think about a case where it wouldn't work. But then again, if we scale the polygon so that we get like self-intersections, then we're fucked. Yeah, I'm gonna have to make it easy on me. I can't include all. We have figured out the edge, like the boundary edges at least. What if we just spawn and then reject if the distance to one of those is too small? And just respawn that shit. And then our upper bound, because we don't want it to go on forever, and just call it a day. Maybe that's it. Maybe that's it. And if we just do it based on triangle, as well, that means that we have it as a plane. That's nice. What I just hate with that solution, however, is if we spawn something on a triangle that doesn't have any edge, that is part of the boundary, so then we don't check. So it's basically comes down to this. What I hate about that approach is that if I'm not careful during setup for each creature, we might end up with a case where we generate something that is totally fucked up. I want the solution to be as safe. Like, I'm going to use this system when I define how to randomly generate these creatures in the future. And I want it to be like foolproof, you know? So in this case right here, fuck, this is what I mean. This won't work. Let's say that we randomize this point. This is not a boundary edge for this polygon, which means that we can't check against this edge, which lies extremely close. You know what? I'm gonna go make a new cup of coffee. So be right back a couple of minutes. Hopefully I've settled on an approach when I get back. Okay, back. Maybe I have an approach we can run with, which works with this boundary and like it's rejection based, but it uses the boundary. So what I'm thinking about is we just do we randomize a spawn point per triangle, and then that spawn point we compare it to the boundary planes. So for each boundary edge we define a plane, and I think that's pretty easy. We're just gonna do we just take any point on the edge, and then we use the tangent as the normal of the plane, and then we compare that point. So we want to check if the distance to each plane is less than something. If it is, then it's a correct point. If it isn't, we regenerate it and we regenerate it at maximum X times, and then we just roll with it. I think that should work. Although, yeah, it's rejection based, but so skip this. We have boundary vertices and boundary edges. I think we're gonna do with spheres. Yeah. And then we do for each. Edge in boundary edges. True. But if, let's see here. In fact, didn't we have, oh, is this just in shaders? We have plane here. Contains distance. Do we have, We're gonna have to do, let's see here. Calculate distance between point and plane. The plane is expressed or is defined by a point and a normal. If the point is on the wrong side or wrong, is the plane normal, distance should be negative. Let's see if it can handle it. Beautiful. Hmm. So we do think it's the tangent we want to go with. And then we check if if this is bigger than radius, actually if it's less than radius, then we'll return false, right? So we define a polygon, in this case Um, so we define a polygon, this one, and for each edge here we create planes. This won't work if we have a convex polygon, then we're fucked. We could define the planes with a size though, then we should be and would need to change the calculations a tiny bit, but concave, I mean. Let's see if it even works for convex first, but I think so. Is sphere within true? So what I want to do next, let's test this one. Do we have mesh parser, debug string get polygons? Where did I define? Random distribution. Yo, what's up, Eldar? Get random point on mesh triangles. We're gonna rewrite this one a bit. Yeah, we need to calculate this. Okay, let's clean this one up and include it in mesh parser. I wonder if we want to store it in triangles when we create those. So triangle, we should have area here as well. Triangle area. Oops. And Antonino, I've been following you for a short time. Yeah, what is it? 2 weeks maybe? I was wondering, how are you, and since when have you cultivated this passion? I'm 34, and like, I've always been interested in developing games. But I began developing games extremely late, I think since I was 25 maybe. Okay, we're gonna do it like this. Mesh parser, we just do normal here instead. Okay, so now we have the area. In our previous solution here, we did it like we created a list with cumulative area while we created the triangles. I wonder if we want to do... Probably gonna do something very similar here, but... wonder if we can do it with link. I think we can. Antonino, yeah, Google Translate sucks. Cultivated maybe is a bit strange for the context. I think it works pretty good. Okay, so I think we're gonna do... I think we are gonna make mesh parser. Hapuka's the cult of dev. Yes, indeed. Get polygons. I'm gonna create here public vector 3 get random point. It was a baller. So we have a list of triangles here. The triangles has an area. So let's see here. Link distinct. I'm not... let's see here. Let's ask method for a cumulative value of elements in array using... Baller, have you ever used Scratch? No, I don't even know what it is. I don't think. Enlighten me, please. It was Upstar. 34, I thought you were like over 20. I mean, 34 is still over 20, isn't it? Parler, it's a coding website for kids. No, I have not. Let's see here. Numbers, select, and yeah. Okay. But we also want to do... We're gonna have to do this as two. Yeah, I guess we could do it like this. Mm. And then we just do. Then we want to do get random point as well. We're gonna get to that one. Hmm. We want normal as well. Yes, I think we do. This is where we want to return a vertex. On a mesh as opposed to that makes up the mesh. Antonino, Scratch is a MTI. It says MIT. Going to learn code to kids. Huh. Maybe I'm gonna look into it. Maybe even introduce my son. Because I've seen someone made a game engine in Scratch language named Glue 3D. That's crazy. Yep. We don't have like a vertex should have an index as well. That's true. Would be beautiful if we could I don't know, I think vertex is probably the wrong... Okay, so the idea is... Fuck, we want to do get random point on... Get random point on polygon as well. Yeah, that's true. Okay, we're gonna keep this one. Is sphere within? Okay, I want to have pretty much the exact same. Okay, we're gonna do it with vertices. Let's check here. Antonino, they were surprised they were, that you were 34 years old. Now you say you have a son. Do you want to give your followers a heart attack? I'm just dropping like lore bits here and there. Where were we? Polygon, yes. So we're gonna go with vertices instead. So mesh parser, when we do this, get random point on mesh. And I'm wondering if we're gonna do it like this. New, primitives, vertex. And if it's not part of the mesh, we just do -1 as the index. Is that weird? But anyway, I want this in polygon as well. Is sphere within? Get random vertex. This is so weird. We don't. If it's just get random vertex, then one would assume that we pick one of the vertices and returns it. Okay, so we do it like this. So the idea is that we do get random vertex on polygon mesh, and then we use that vertex and we check. So that's the spawn vertex, and then we check we use the position of it here and then a radius based on the object we're gonna spawn. If it fails, we say fuck it and continue. Okay, let's see here. It's been a while, but how do we get back to... Apukas, he will bring his kid into the dev cult as well and will develop games together. You don't know how true that is. Like, I introduced him to gaming when he was like 2. And soon the final step, or we're gonna start the final step, which is introducing him to game dev. Robin and Company games. Hell yeah, bro. Robin and Son Entertainment. Sounds like a brand from the 70s. Family owned business. Hell yeah. Rob and Son Entertainment. Still a couple of years left, I think. Okay, I want to try this now. Let's see. Hopefully we can make it without crashing everything. So what do we have? Visual property generator. Oh yeah, we're gonna have to define this as a me. Rob and Son and Robinson. It's a very... I didn't give you enough credits. That's actually pretty good. Antonino, I was wondering if you recommend studying game dev and then working in the industry. Did you do something like this? No, like, I didn't study game dev. I have a Master of Science in computer engineering. And I've never worked, like, as far as game dev goes, this is working in the industry for me. Just streaming this and working on my own games. I've never worked in the industry, but I know a few people that do and has. I can't speak for them. But I think it's a fucking hard field to work in, you know? Doesn't seem to be very creatively fulfilling these days. Depends on the company, but I get the feeling that most of the companies are run by quote-unquote men in suits that are profit first. And I don't think that's very fun to do. Maybe if you don't care about the end product and you're just in it for the problem solving, because game dev is I think the problems you run into during game dev is extremely fun and much more fun than, I don't know, say any problems I've run into in web dev. So if you're only into it for the problems, then it's maybe fun, but I don't know. If I got Pukas, it's probably way better at answering this question than I am. Okay, let's see. We had a module system here. Module position by mesh, module position by shape. And it's this one we're working on, right? Game misc distribution, yeah, okay. Module position by mesh. Let's see. I think I want to... Module position by mesh. Let's take this one and apply. Then we have the mesh and we do rotate based on mesh face. And then we have apply. So I guess here we can just do this instead. Private mesh parser. To modules. Could we do... I think I want reaches here as well. Eventually we don't want to like create this one multiple times. We're gonna improve this one, but let's see here. For now we're just gonna do mesh parser is equal to new mesh. Okay. Mesh, and then we do apply. So we want to get random point on mesh triangles. Then we want to set local position. So let's do visual or we do this, get random vertex on mesh. We're gonna do this a lot of times actually. Apokas appreciate the nice words. Sometimes it doesn't feel like it though. Okay, let's see here. I just want to try what we have implemented now and see if it works. So right now, the way I'm implementing it now is extremely unoptimized, because this means that we're gonna regenerate our mesh parser every time here. But I'm okay with it just to test. Hopefully nothing will crash. So what I want to try here is this is crazy. If we were to do the same as this, it would look like this. If mesh parser dot get polygons, ooh, that is true. We want to get a random polygon, and then we want to get a random. So I guess it's going to look like this. We want to get a random polygon based on area, and then we want to get a random triangle based on area, and then we get the random point. Okay, and then we check if the point is within the polygon with the visual object radius. So mesh parser, get random vertex. Get random polygon on mesh. Yeah. So we're gonna have to do this instead, and then we do polygons. We haven't implemented this one, so we will. Cumulative areas, total area. Everything. This one we're going to change to polygon index. And here we do what do we call this one instead? Get random vertex on polygon mesh. No, here we just want to return this one, right? Get random polygon on mesh. And then we're going to do get random point, yeah. Do I want to calculate the area here? Yes, we do. For each triangle in triangles. Uh, oh, true, 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 true. Now we have this. Okay, so back to module position by mesh. Polygon. Let's just send in 10 for now. And then we do if polygon dot is sphere within, and then we do vertex position and visual object here. I don't think we have a radius for it, which sucks, but we can do we could calculate it from the bounds, but renderer bounds. Scale range. Hmm. if this is false, then we do... Okay, this is the fucked up, but I think for now I just want to test this, so we're gonna do destroy. Don't we have visual object? Otherwise, we do this one we already have. We want to do visual object transform local position is equal to vertex dot position. Rotate based on mesh face. So rotation vertex. Okay, something like this. I mean, this type of streams, blogs attract people either who are interested in creating games or like-minded persons. Yeah, 100%. Honestly, like reading other people's progress with their games in a blog or watching their well-edited devlogs, I find that extremely fun. And sometimes you learn a thing or two. Okay, let's try this. Let's see if it crashes. I'm a little bit worried. I'm not gonna lie. So let's see here. Oh yeah, we had it in creature stand definition, attribute generations, visual property generators, element 0. What do we have? Position by mesh module. And then we have scale module here. I think we're going to scale it first. Position by mesh module, creature stand based model, rotate based on... Yes. Okay, hopefully it won't crash. We will probably get a few less eyes than we did previously. And like best case scenario, what we're aiming for here is that we don't get any eyes that hang outside the edge. But we'll see. Because like Robin videos, watch. Yeah. That is unfortunately the same reason we haven't seen any of like videos lately. It takes too much time. But fuck, I've been dying to continue editing them. And I will. Because I mean, I would like to do devlog videos, but every time I hear my own voice and accent when I speak in English, it makes me cringe every time. Dude, I think that's relatable for most of us. Personally, what the fuck, what is the word I'm looking for? Anyway, I I overcame the cringe of hearing my own voice because the power to do devlogs and videos were too strong, you know. But like doing the voiceover and cleaning up the voiceover audio, that's like my most disliked part about doing these devlogs. And that's why I've been talking about, like, I would love to feed a LLM or a generative network my voice recordings and just fucking generate the voiceovers. Thank you, Apukas, appreciate it. Like those first videos doing the voiceover took so long. And I also do... Yeah, I appreciate it. But soon, maybe soon, generative voice or AI will be able to generate a pretty good voiceover using our voices, you know? But okay, let's try this one. Fuck, it's gonna crash. Okay, if the stream goes down, you know why. Okay, we rotate it wrong. It should be rotated like this, but that's okay. Yeah, this is worst case scenario. So for this stone, I think we probably spawned some eye here, maybe. It failed, and now this stone has 0 eyes. It looks pretty good so far. I probably want to spawn the eyes that failed as well and just mark them as red or something like that. And then we need to get the rotation correct as well. I wonder why it failed. For one sec, what about this one? Ah, it's okay actually. I'm not a big fan of these rejection-based random approaches, but sometimes that's the only thing you can do. What's up, Anton? Hope you're having a wonderful Tuesday. I wonder why these eyes got spawned with the wrong rotation. Did I fuck up the normal of the triangles? Maybe. Antonino, my English was so bad I had to cancel the message. That happens sometimes, man. Just consume. I don't think you need to take an English course. Just consuming English content and talking like you do now. Okay, let's do it like this. I want to test this. I want to do a better test. So instead of destroying it, we're gonna spawn it, but we're gonna mark it in some way. Let's do it like this. error material, and then we're just gonna do visual object runner dot material is equal to error material. And rotation here, vertex normal. Did I fuck this up? Vertex normal. It's the opposite of what it should be. Mesh parser. Actually, it isn't. What the fuck? Now, vertex normal, we just take the normal of... It should be okay. It should be okay. Did I have a minus here previously? We'll get to it soon. I want to try... We're going to set the error material. And yeah, let's see what we get. Prototype red material, that will work. This one failed. It's outside. This one failed. It's outside. Like, by doing this, you get a lot of failed eyes, or a lot of failed visual properties. Oh, yeah, I get the rotation, I think. Or do I? Yeah, I do. Do I? Remove this one. Remove this. With this approach as well, if you do this approach... Wow, did this one actually succeed? Yeah, it did. If you do this approach, you're also going to minimize the chance for an eye spawning on a small polygon like this, which I don't like. Apogas observe as his brave Homo sapiens boldly attempts to summon a 3D modeling software inside Unity. Unfortunately, I can't read it in BBC voiceover, but I approve the message. Did this one actually fail though? Yep, there we go. Okay, yeah, this works, but I'm not a big fan of it. Bro, you're creating Blender's particle system inside Unity. That's better than recreating the Blender modeling. at least. Okay, that's good. Okay, this looks pretty good, but the distribution is fucked, I think. And then I wonder why the rotation here is wrong. Can I get local? Why are we getting inverted? That makes no sense for me. Ah, one sec. Local position vertex. Yeah, the vertex we get here. Get random vertex on poly. We create a new vertex here and we take the triangle normal. Are my triangle normal fucked? That's not good. Yes, yes, yes. Why did I do it like this too? Rewrite. That's good to know. Okay, this looks good, but it's just so fucking depressing that we have like generate 3 eyes, only 1 succeed. When we do rejection based like this, we're gonna generate the point, we're gonna get the point. If it doesn't work, we regenerate the point, which means that we will get more eyes. But like getting eyes on these surfaces are gonna be extremely rare, but maybe, I don't know, maybe that's a good thing. We haven't even begun doing overlapping eyes yet. This one actually gets 0 eyes. That's pretty weird. That is something we definitely want to avoid as well, I think. Looks like some sort of sickness. Antonino, quote, fuck this shit, I'm gonna create my own 3D modeling software, unquote. Yeah, that's what I'm afraid of. Like, it's a thin line to walk on. If we want to get proper procedural generation, that's probably the black hole we're gonna end up in. Best case scenario, we end up with a particle simulator Apukas recreated. Okay, but this is good-ish. Okay, we could do it like this. Module position by mesh. This one we don't want. But we also want to have spawn. Let's do it first, actually. Spawn tries plus plus, and then while spawn tries is less than max spawn tries, and this. But you know what? Then we're gonna have, if we write it like this, we're gonna have an additional check, or we're gonna need to have an additional check. Maybe. Spawn success is sphere within. If it's within, it's a success. We increment spawn tries. Less than max spawn tries. So if this one is true, we exit, or if this one is not true. Yeah, let's hope it's good. And we can start with one. Okay, it looks pretty good. Let's try 10. Apukas, have you used any other AI agent besides GPT, like Claude Code? No, I haven't. Actually. I don't know if it's good enough without paying. Sorry, I can't answer that question, but like I've been meaning to, just haven't gotten around to it yet. Oh, here we actually got a spawn here. That's pretty cool. On this polygon. But if we get one spawn on this one, that would be amazing. Okay, I mean, this works. It's not the best, but works. Sometimes that's enough. I want to make them a little bit bigger, the eyes. Ooh, this one is right at the acceptable edge. Let's go a little bit more crazy with the scale. Here, scale range, keep ratio. So to 0.1, go double. Sec. If we do double, do we need to double this one as well? It looks too weird if it's too big. And we need to fix the overlapping as well. Yo, what's up, Jax Unicode? What's this logo? What logo you mean? Okay, it's a little bit too big. So we had 1, 4. Let's do... Ooh, we actually got it. We got an eye spawned here. That's pretty cool. Okay, next up we're gonna have to solve this. I think it's pretty straightforward. Or it depends on how we wanna... How many times have I said that something is pretty straightforward and then we end up working on it for like 4 streaming sessions? Antonino, why am I writing like 5 letters for messages? The more messages, the more it helps me with the algorithm, at least. That's good. But what I'm thinking here is that, yeah, we define the boundary of this object in some way. We could go with the rendered boundary. That's pretty easy to do. I think we're gonna take that one. But that means that we can't get eyes like... If we do use the rendering boundary, we won't be able to spawn eyes like this. Because the bounds are boxes, and these will have overlapping boxes if we do it like this. But maybe that's okay. In the beginning. So in this case, it's probably just visual property generator. So the visual objects we create here, we need to keep a list of them and check so that they don't intersect with something. I think that's pretty much it. And then when we apply a module, we just check. Do we check it after we apply it here? Maybe. I'm gonna have to refine this system a bit. The modules, rotation and scale and stuff like that. I mean, maybe I just overdid it a bit when I visualized it, or when I thought about it like a modular type of thing. Or let's do 10 minimum, 20 max. That's pretty crazy. takes quite a long time as well. And then we just remove Still a little bit of a selection artifact here. What is this? What's this about? Why? That's very weird. But I'm not going to look into it right now. So what I'm thinking is we're going to do something like prefab range, serialize field, allow overlap. And then we do... Can we regenerate stuff by... We can just call apply here, can't we? Huh. Maybe we should be doing this outside. We're going to refine this system, or we're going to iterate over this system quite a few times. But allow overlap. Generate. I don't think we want to keep... Nah, we don't want to keep it after, so list game object. Okay, we're going to create a class for this, which we add here. Doing a mono behavior class here might be a bit over the top, but we want to keep references to like renderers. We want to have a transform. We want to have quite a few things actually. Okay, basically what we want is something like this. List, game object, spawned, visual objects. And after we do the mesh parser, we definitely want to keep this one in visual property generator, because then we don't need to recalculate it every time. I don't want to do get component here every time. Okay. Let's do this proper. So the idea is that or like what I think is going to be the next steps is that we're going to create a class that is for our like visual objects. So whatever we spawn and add to a creature. In this case, an eye. That visual object is going to keep, or that visual object is going to keep a lot of data at hand. Because basically what we need to do here is we need to loop through all the objects that are already spawned. We need to get the boundaries of those, or bounds, and then we need to check if we have any overlap. If we have any overlap of bounds, then we want to recalculate the position. As a worst case scenario, it would look Maybe we want to do it here actually. After here. So if for each game object spawn and then we check I guess this would be the ugly way to do it, but this is basically what we want to do. And if bounds a dot intersects bounds b, then we do destroy or game object dot destroy visual object and continue. Like we want to break this and this one, so that sucks. Actually, do we? Yeah, we're gonna try something like this. So we shouldn't be getting overlapping eyes now, but we'll see. Antonino, I'm really confused about my future. I like design, computer science, electronics, game dev in general, 3D modeling, texturing. I just want one passion. Fuck, you have no idea how relatable that is. That's crazy relatable. I don't think we have any overlapping eyes here. So yeah, this works, but extremely ugly and unoptimized. We're gonna refine it tomorrow, and then we can move on, I think. But I gotta run now. Gotta do some other shit. I mean, we did some progress today. I still feel a little bit bad that we had to jump ship on the clean implementation and rely on a sort of rejection-based random point generation algorithm, but sometimes you gotta eat a loss. We'll continue this tomorrow. Thank you so much for watching. Appreciate it. And chatting, interesting. Always. Have a great rest of the day. Peace.